Hello and welcome to my game dev live stream. This is number 53. I'm gonna keep working on saving and loading files. So I think last time we left off we have this file system script here. And it has a save object function and a load object function. It takes in a file path. And an object to save. With the file path it opens up a stream, and then with the object it does to JSON. And then we write it to the stream and we close it. Well, we also convert string to a byte array. I was thinking about how to actually make this work. Like, is there a system that tells what to save and what to load? Like, does everything just call this? Seems like a lot of repeated code. So I think my solution is that I have a file system which contains a list of things to save, and I guess Steam rebooted, whatever. Got a file system which keeps track of everything that needs to be saved and loaded, and then it calls all the associated functions. So oh my god. Alright, let's get Steam closed. Don't want Steam open. Trying to open OneNote here. File system design. Maybe just file system. So over here we have all of our persistent objects. We have a savable interface. We have a file system, and here we have all of our files. This says how to, or this says what and where to save. So I think this persistent delegator has a map of savables to their file paths. And this is a mono behavior. Hi JJP, AGP, BTRF. Thanks for joining. Sorry you haven't been able to send messages. I've heard that people are having this issue. Thanks. Right now I'm working on a file system. Trying to figure out how I want to be able to save and load things. Call this persist. Oh, just gonna delete that, make a new one. Persistence delegator. C# map dictionary. gonna watch this video. I saw this one when I was wrapping up yesterday. This guy's talking about saving scriptable objects and persistence. So I think this would be pretty useful.
A feature of Unity that's been gaining a lot of popularity lately is scriptable objects. Scriptable objects have been featured in a few good Unite talks, which I'll link in the description below. They're really worth watching. And I've noticed a rise in videos from Unity YouTubers on the subject of scriptable objects. And there's good reason behind this, because scriptable objects are really powerful. In the recent videos and tutorials I've been watching, I've noticed some emerging trends which could lead to certain problems. A lot of the tutorials I've seen are showing you that you can save your game data in scriptable objects. And this could lead to problems down the line. While you're in development, then you can edit scriptable objects as much as you want, or enter play mode and continue to edit those scriptable objects, and everything will be persisted. Whereas when you create a build of your game, those scriptable objects then become static, which means you'll no longer be able to use them as a persistence tool. So as of right now, I'm very worried there's going to be a lot of developers who go through the whole process of creating all their save data with scriptable objects, only to get to the end to find out that they're going to have to figure out some way of managing that.
That's about where I'm at right now.
So in this tutorial, we're going to look at how you can persist your scriptable objects without having to make a whole lot of changes to them. Okay, so over here I have a new project, and let's just make something quickly to get up and running. I'm going to create a scripts folder and a scenes folder. In the scripts folder, let's create a new script, C# script, and I'm going to call it Scriptable Int. Okay, we're going to keep this class fairly simple. It is going to inherit from Scriptable Object, and it'll have a public integer of value. Okay, so it's a very simple scriptable object. I'm also just going to add create asset menu up here, so that we'll be able to create the object from the asset menu. Save the script. Okay, now let's just create a new folder called variables. Now in here, let's come up to create again and go to Scriptable Int, and we'll just call it counter. And let's just set the beginning value to 5. Okay, now let's create another script, and we'll call it text updater. Okay, in addition to using the Unity engine, we're also going to be using unityengine.ui. At the top of the class, let's add a public scriptable int, and we'll call it myInt. And we're also adding a public text called myText. So this will hold my scriptable integer, and this will hold the text item that I'm going to be updating on the screen with the text from the integer. Okay, so we're just going to leave the start function there for now. And we'll start a function, public, it'll return void, it's going to be called add, and it will take an integer called amount. So there we go, basic stuff. We're just taking the integer, adding on the amount to that integer, and setting it. Let's also create another function. This one's just going to be called refresh, and it'll return void. Okay, we're setting the text property of myText to myInteger value to string. Okay, so we want to call that whenever someone adds something to the value, and also when the application begins. Okay, so that's all we need in our text updater class. To save that, come back into Unity. In the hierarchy, right click, UI, text. So it's added a canvas for us and a text item. And let's just set the canvas scaler to scale with screen size. Okay, now let's just make the text a lot bigger and center it in the middle of the screen. Take up the font size, change everything to center, change its color to white. Okay, that should look pretty good. Let's just set the text to nothing for now. Now let's also add a button to our canvas. I'm just going to move that down to the bottom of the screen, align it to the bottom, open out the button and change its text to add 1. Okay, now to our button, let's just drag that text updater onto the inspector, and we'll add the counter object to myInt, and we'll drag that text that we added earlier onto myText. Now the button will also have this onClick event, so if I click that, drag on the object, come down to text updater and change that to add int, and we're adding 1, so I'll set this to 1. Okay, don't forget to save your scene. I've just called mine scene. Let's play the application. Okay, you can see 5 being up here, which is the number we set in our counter. If I hit add 1, it'll incrementally increase that number. If I stop the application, which is, let's say, equivalent to exiting the application, and then open it again, that number is still 8. So the state of our scriptable object has stayed the same, even though I exited the application. Change it to 14, run it again. Once again, it's still that same number. Okay, so what about when you actually build the application? So if we come to our build settings, drag in the scene, and click build. Let's choose a location for this. I'm just going to create a new folder called builds. And I'm just going to call it object testing. Okay, and here's my build application. If I run that one, and tell it to open it windowed, Okay, you can see that it's kept the same number that was in there at build time. So I can now add to that number again. However, when I close the application and then reload it, it's reverted back to 14. So as previously mentioned, now the application has been built, this object is now static. So anyone who's using scriptable objects for saving data will run into some problems here. There's a few different ways that we can make this persistent. Let's have a look at one of them. So in our scripts folder, let's come up to create C# script, and I'm going to call it persistable SO for scriptable object. Okay, let's start by removing the start and update functions, so we won't be using them. And in our using, we're going to add using system.runtime.serialization.formatters.binary. So this is what we're going to be using to save the state of our scriptable objects to file. And then because we're adding them to file, we also need to bring in system.io. Okay, we're only going to be using two functions in here, so we're going to add onEnable and onDisable. So whenever this object is enabled, it will restore the state of our scriptable objects, and whenever it's disabled, it will save the state of the scriptable objects to file. Okay, so at the top here, I'm adding a list of scriptable objects. I'm just going to call it objects to persist. So not all of our scriptable objects will need to be persisted, only the ones we're using for saved data.
This is basically the persistence delegator I was talking about. What I was missing was, well, let's see if his solution resolves this, but basically I'm concerned that if I have two scriptable object instances of the same type, like if I have, in his example, if I had two scriptable ints and I tried to persist both of them, when I reload them, it wouldn't know which one is which, and it might load the wrong data into the wrong object, which might have other references. Other objects might be referencing it, and loading the wrong data into it would be catastrophic. Like, the sun would implode and we would all die. Kind of catastrophic. So, moving on.
Data, or even options data. And I'm also going to give a name to this object, that's just so that we can keep it unique in case we're adding multiple persistable objects. And that'll make more sense as we go through this process. So let's start on saving data. So on disable, I've just copied in a for loop here, so for all of the objects within our objects to persist, so this list up here. We're going to create a binary formatter and a file stream. So the binary formatter is what will encode it, and the file is the file that we're going to store it in. So the file stream called file is equal to file.create application.persistent_datapath. So if you haven't used application.persistent_datapath before, what they'll do is for whatever platform you're on, it'll give you the path to where you can store some data. So if you're on Windows, Mac, or mobile platforms, this will give you a safe storage location. And we'll have a look at that in a bit more detail soon. So to this persistent data path, we're adding a string of format. It's going to be 2 items and .pso for persistable scriptable object. The first part of it is going to be the unique name that we're giving to this collection. The second part is going to be the location of...
I was muted. Basically, it's seeming like he's going to use this incrementer I to make each one unique. And that kind of makes sense. I was thinking of doing something like that, but I don't like the idea that this... I don't like the idea that the persistence delegator gets to decide what the name of things is. And I'm still not sure I trust that the ordering of this list will be the same each time. This list he's talking about, what if it's a different order? I don't know. What if it gets reordered or something like that? He might talk about that too.
The object in the array. Okay, so now that we've created the file...
also he's obviously using the deprecated binary formatter. I have a way around that, not really concerned about that part of it.
We need to turn our scriptable object from a scriptable object into a plain string of text. The easiest way to do that, and the most reliable way, is using JSON. So a variable called JSON using the JSON utility to JSON, and we're just sending the object at the current index. So that'll be the scriptable object at this index in the array.
I was also skeptical of using JSON utility.toJSON to persist or to serialize a scriptable object. I had read somewhere yesterday that you can't just serialize a scriptable object because Unity has all sorts of other data associated with it. I don't know if that's true or not. I guess maybe he'll post the file here. It's got a GitHub. Maybe I could just go look and see.
Then we're just going to use our binary formatter to serialize our JSON into the file and then close the file. Okay, so if I come back to Unity now and create a new game object that I'm just going to call save data. Let's drag the persistable SO onto that. Give it the name main. Now in the object to persist, let's give it 3 objects. And what I'll do is just create a few more variables. Now you can use any scriptable object here, but I'm going to just keep using my scriptable int because I'm sure we're running short on time. Okay, so now we have 3 different objects. I'm going to add some numbers to them. Come to my save data, and let's just drag all of them on. Okay, so on disable, all these items will be saved to a file. So if I run the application and close the application, all of those would have now been saved to a file. Now how can you find where this file is? We have a look under the build settings and then player settings. This is for Windows, by the way. For Mac it's slightly different. So I'm going to see here I've got my company name and the product name. If I come into C drive, users, my name, app data, local low, I should have this company name up here, which is default company, and then the name of the project, which is saving data scriptable object. For yours will be whatever is in your product name. Okay, so now we can see those 3 items that we made. So we can see we made the name of it based on the name of the object, plus the index in the array. If I open one of them in Notepad, there's going to be some odd characters because we've serialized it, but you also see...
Okay, so he does show the file here. What is that stuff going on before there? I would like to know.
Our JSON in here is plain text. For the property of value, we have it set to 14 in this case. Okay, so that's saving data. Now how do we bring it back in? Come back to the persistable SO, and this time to the onEnable. Okay, so once again we're starting with a for loop that will go through each of those objects that we have up here. And then the first thing we're doing is checking the file path, so if file exists at the persistent data path, and then that same string that we used earlier over here. So if a file exists at that path, we're once again creating a binary formatter, and a file stream, this time with file open, whereas last time we were using file create. And once again that same path, and then using file mode open. Okay, so we've opened the file. Now let's use the JSON utility again with from JSON overwrite. The override is important. If you use just from JSON, it's not going to work. Okay, and we're deserializing the file as a string, and then overriding it to the object at the index in this list. So we're taking the file, we're deserializing it as JSON, and then we're using JSON to create the object and override it. Then when all that's done, we can close the file, save the script. Let's come back over and test if that works. Okay, so if I add one now, close the application, reopen, it's still working as before, except now the file is getting saved and loaded each time as well. So now if I build the application again, okay, so that previous number was 17, let's add to it to say 26, close the application, reopen the application, and there we go, it's still 26. So you can potentially keep adding to this persistable scriptable objects array, and all the objects will be saved and then reloaded every time the application is open and closed. You may want to handle it differently in your game, but this should be a pretty good boilerplate set of code for you to get started with. Being able to export scriptable objects as JSON can be really useful, especially in cases where you want to save your data in the cloud. It's a very easy way to pack all the data into a couple of strings and then send it off and then retrieve it again later. Alright, so I hope you found this video useful. If you're curious about editor scripting and cleaning this up to make it look really useful, I have a course on editor scripting at the moment on Udemy. I've got links to that in the description below. I'd really love for you to check it out. So thank you for your time. I hope you found this useful. I hadn't found any other sites that were really covering this sort of functionality. I pretty much threw this example together because I couldn't find any boilerplate code on the internet already for it. So good luck and keep using scriptable objects. They're great.
Wow, that outro was so much more dramatic than the video itself. The music that was playing in the video was very mellow and calm, and then it was just like ripping on a guitar at the end. So here this commenter notes that in the code he's doing both. He's doing to JSON and then also serializing it, and he's noting that you don't actually need to do both. One distinct idea that this guy had that I hadn't considered is that you can have different objects sort of be the masters of their own persistence, which is sort of opposed to my persistence delegator idea. So I think I'm going to call this a persister instead. So one problem that occurs is if you delete or reorder the persistent data. Like, once you decide to do this, it becomes a big hassle to make something no longer persistent. Because now you have a file out there which is not going to be the correct piece of data, and everything that follows is also not going to be the correct piece of data. So say you delete one from the middle, and then you add some to the end. Everything is going to be off by one after the point at which you deleted the one. Oh well, I'll cross some bridges when I get there. So this is going to be directory. We're going to have a public list of scriptable objects, or scriptive savables. Objects to save, objects to persist. We also need a new function that says, does a file exist? Why did I decide to use file stream? I'm not sure I understand that. The answer is because I still need a file stream, I just need to use something else here. It's like file dot exist. S dot restore from data. We'll do file system dot load data. S dot get file. So, what happens if the file does not exist? I think this still needs to happen. I also think that this needs to be an array. Well, the thought for making it an array is that if, well, I don't know how this works in C#, but in Java at least, if you remove, like most of the time, if you remove an element from a list, it doesn't stay empty. It just takes that node out of the linked list. I don't know. So I'm doing a build here to sort of prove that it doesn't persist the player location. It's like trying to prove that to myself or something. So I'm going to keep the player up here. And then, I don't know, I guess get out of here somehow. Just close this. Now if I run it again, the player probably not going to stay there. Yeah. So now I'm going to add a persister to the dynamic character. That's interesting that the list is not showing up on there. Why is that? Is it because it's an interface? Oh, so they only show up in there if they're serializable. I probably can't do that for an interface. Yeah. Okay. So now I've got that kind of set up. What I want to do is make the scriptable object data for the player a persistable scriptable object. So the character health data, the character kinematic data. There's an issue here. I gotta do directory plus / then I gotta add a .dat at the end here. This seems like a private static string build file path takes in string directory takes in a persistable SO. Okay. I don't know at all if any of this is going to work, but let's wrap up for today. And hopefully get something cool to work next time. Thank you for watching, and as always, have a nice night.